Alright, welcome to Meteorology 101. In this video I just want to talk about the low pressure system over the Gulf, maybe eastern Texas. Let's see where that placement is and just cover some weather charts, just basic. I'm not doing any major forecasts here. We're just doing what I want to do is a front placement and pull up some weather charts. I want to build some weather charts. We got a program that analyzes data, build some charts and see where these cold fronts are placed, warm fronts. Looking at the radar, I would say you have one or two things going on here. Either have a front, pull up my drawing tool, going through here with a prefrontal trough, or we could just have a low pressure system up here and then a cold front coming down along that line of precipitation into the Gulf, into another low pressure system. Looks like rotation here. We'll pull up the chart, see exactly where it is, but just want to show you just some basic stuff on chart analysis. Alright, so I run a program called Digital Atmosphere, and every hour observers go out and they'll send out an observation at every weather station across the United States with cloud height, cloud cover, winds, temperature, moisture, dew point temperatures. Some of them are automated. They have an ASOS. It's an automated surface observation system, and that will send out its data. You gotta be careful with it for cloud heights. It's not real accurate. It just shoots a beam up to the sky, and any reflectivity that comes back, it tells you, it judges how high the clouds are. If there's no cloud directly above it, then it's not going to give you a height. So anyway, I can download that data that's put out every hour, and then this program will analyze the data based on lines of equal temperature, lines of equal pressure, and these station plots that I'm going to pull up. Okay, so this isn't every station plot across the United States. If I put those in there, this would be just kind of a black screen. You won't even see anything. So I go about 80, 85%, something like that. I go to the 84% of the stations that are downloaded. So a lot of buoys out in the Atlantic, down in the Gulf, over the Pacific. So we can use this data to just judge where our fronts are and verify the weather charts, the weather that's going on, and what's causing it. So if you look at the red, this red indicates IFR conditions. That means the ceiling is either less than 1,000 feet or visibility is less than 1 mile. Blue is a marginal VFR, and that means that the ceilings are between 1,000 and 3,000 feet, or the visibility is between 1 and 3 miles. And then the black dots are VFR, which is visibility above 3 miles and cloud height above 3,000 feet. So that gives you an idea where your lowest clouds are and where your precipitation is taking place. Plus also these things put out, when they put out the observations, they put out these little areas next to the stations that show precipitation. So that's like light rain. You gotta know what those mean. Like this would be like mist, like mist or fog. That's what's causing the visibility to be low. This could be like a heavy rain. There is a chart that tells you what all the weather icons are for the weather at those stations. Then these wind barbs, they come from what the wind direction, and then each one of these notches are, the long notch is 10 knots, the short notch is 5 knots. So if we get into 2 long knots, that's about 20 knots of wind. Then one long, one short. It's about 15 knots of wind. So that gives you an idea of what, and then what direction the wind is flowing. So if we build this chart, we have the station plots. Let's go with, we're going to go with sea level pressure. This is on the surface, and that's a adjusted sea level pressure because every part of the United States isn't at sea level, so it has to be adjusted for the equal pressure. The computer generates all that. So if we look at it, we got high pressure over Illinois, the southern part of Lake Michigan. That low pressure system, this is showing the low pressure center at the over the Gulf. We were saying more like over East Texas, just looking at that radar. So if we analyze this, just looking at that low pressure system, we have winds out of the southeast, the east-southeast, and then we've got a wind shift here too out of the northwest. So we definitely got rotation here. So with the winds out of the north there, we could have some rotation right there. So that will place that low more over eastern Texas. So this wind barb there, there. So you could just have a big elongated low pressure system right there. That could be accurate too. The problem with this is there's not much data over the Gulf Coast to really narrow that down. But low pressure system. Now we'll throw in the clear this out. We'll throw in the lines of equal temperature. So if I do Fahrenheit, it gets pretty crowded. So I'm going to do Celsius. That keeps not so many lines on the screen, and we'll be able to see it better. And pretty much all the temperatures, them are all Fahrenheit here. Just on the surface, upper air is all Celsius. But looking at this chart now, on these lines of equal temperature, those are isotherms. The lines of equal pressure are the solid lines. Those are isobars. And then you have the station plot. So let me get back to drawing mode here. Now if we do, I guess I'll try to keep this to correct colors. It's going to be tough to do when using a stylus instead of a mouse, but the stylus I could draw better with, but clicking on this stuff is a little bit tougher. So this is going to not look so neat, but just bear with me. So it looks like we have low pressure over the northeast. We have a cold front possibly coming down through this trough. You got to look at the winds when you're analyzing this. That's what I want to cover, because these winds are out of the northwest. This wind's out of the southwest. So that would place that front pretty much right between there, right into that trough. Now we have high pressure over the Atlantic, high pressure over Illinois. Now you got two high pressure systems. This frontal system, you have a cold air advection. Those lines of equal temperature get colder as you go north. The winds around the low pressure system are counterclockwise. So I'm going to reset that. The winds blow out of the northwest. Around the high, they're clockwise. And then around this high, they're clockwise. So when you have that frontal system come through the trough, and then you get between two highs, you got winds coming out of the southwest, and then there'll be winds out of the northwest. So then that's basically that front becomes, I'm not going to have the right colors. It should be red on the warm side, cold on the cold side, and that should be blue. This is a mess. So, and then we're going to go stationary. Okay, it changes the colors on my lines anyway. So stationary front between those two highs, and then once we get back into the circulation around the low being counterclockwise, and these isobars are together, now we got an area of warm air advection because we're pushing these lines of equal temperature that are warmer into the lines that are colder. So now you got warm air advection. So now what you're looking for is the wind shift and the temperature differences. 65, 54. Winds are out of the northeast there. Winds are out of the southeast there. Winds are out of the southeast. Looking for that change, and that's where you could put your warm front. The winds are blown out of that, and then you can put your warm front on that where that thermal advection is. So you can place that warm front there. Now we did have that cold front coming down into a stationary front, and then coming in back into a warm front, because you have warm air advection all through here, and then coming out of that low. Excuse me. Look for another wind shift. That wind's out of the northwest. Wind's out of the northwest. We could place that cold front probably somewhere in here. Now we'll put up a thickness chart that's going to give you a little bit more data to analyze and show the placement of that front. But with the circulation around the low pressure system, winds out of the northwest, winds out of the southeast, that's your warm air advection to your south, your cold air advection. So that's just some basic information on the frontal placement. Now if you look at it, just the red with the IFR conditions, that's a lot of warm air advection through here, and then that's getting pushed up over this cold air that is this high pressure system. It's just a big cold air moving to the southeast, and then that warm air starts riding up over that cold air, and then you'll get a stable environment. That's where you get steady rain, fog, and then depending on how cold that air mass is and how high the freezing level is, any precipitation that falls out of that moisture through that air mass, if your freezing level 600 feet or less, then you'll get snow. So not likely to happen down here, possible though. What we typically look at is like this low pressure system start pushing up over that high. If that high doesn't move out fast enough, get absorbed into this high, then you can get that overrun, and that's pretty much what we're going to have here with any snow mixture, over the Midwest right there. So a lot of the precipitation happening all along those fronts. So if you look at that, come on, get this straightened out here. Alright, like I said, with that frontal system, now that low pressure system, I mean, just based on this precipitation, these bands of precipitation right there, I would say you got that warm air advection going on with that low pressure system approximately right there. I mean, you got that elongated low, warm air, stationary, and then the cold front. So, and then then pulling back the cold front back through here to Mexico. So that would be my initial placement there. Let's pull up the satellite, see what we're looking at there. Need to be on that screen. The same thing here. If you look at the clouds, you could almost say, go to the draw mode. Let me get this pulled down here. That looks like a maybe like a prefrontal trough right there, the low pressure system. I don't know why I drew a 4, but that's a low pressure system right there. Almost like a cold front right there. That would have to be a prefrontal trough and then a warm front. I had the kind of cold front coming back here. We'll pull up a thickness and see what's happening there. Now, another thing that can happen is too, is you get a low pressure system that's pretty much stationary, and then you'll have these shortwave troughs going around that low, and then you'll just get precipitation, then a break, and precipitation, a break. You know, that could happen too. So this is just a developing low pressure system, so it's kind of, you know, it's starting out, so it's not really moving much. The high pressure is getting out of the way, and then, you know, so this low pressure system has nowhere to go. High pressure always rules, so the high pressure has to get out of the way before the low can go to push to the northeast. If the high pressure system doesn't move, then that low can't go anywhere. It could just sit right there, and just either it deepen, get stronger, or to fill from the high pressure dumping into it and fill it, and then it's going to be just dissipate. So let's go back here. Alright, high pressure area, that's just cold air. Like I said, circulation around the high is clockwise. Get my draw tool. And then anything, when these isotherms cross the isobars, that's a baroclinic system, so now you have temperature advection. So now, since your wind flows clockwise around a high, then you have cold air advection coming from the north, warm air advection coming from the south. So that's your rotation. Now this high pressure system presses down, you know, higher pressure on the surface, so it kind of wants to stop any development of anything coming up and being lifted, you know, that moisture to be lifted to cause any major weather. But you can get overrunning when this high pressure system moves to the southeast. Then that cold air just rides the ground, and then any warm air it runs into, like all this advection here, then it would push up over that high pressure system, and all that moisture gets lifted, and that lift is what you need for the air mass to cool and become saturated and cause the precipitation. I mean, you can look at all the low clouds there anyway. So I think that's pretty much all I want to cover today. Let me pull up another chart. We'll pull up that thickness chart. So with this program I can run a thickness chart. It takes a minute to build. Back to that radar. So like I said, we should see low pressure. Looking at these bands, let me go. Well, I just messed up there. Put all the counties and everything on. I don't know if I had to reset it or not. That's alright. So close this. This stylus is terrible. I need a mouse. I left it at home. So we're going to draw here. Like I said, the low pressure system, pretty much where I placed that. Once I place that position, like I said, put that low, warm front, stationary, cold front, and then like I said, cold front. Let's see how that works out on the thickness chart. Okay, that's the complete. Now what this added was isobars, the lines of equal pressure, isotherms, lines of equal temperature, and no, it didn't. It added the height at the 500 millibar level, so 54 meters. This purple line, the 540 line, call it, is the rain snow line. Anything along that line, man, this thing is a joke. So, alright, anything along that purple line, any precipitation that happens along that purple line is going to be a mixed precipitation, rain and snow mixture. Anything north of that in the cold air is going to be snow. Anything south of that is going to be rain. So that's your initial look at what type of precipitation you're going to get. So this high pressure system, if it just sits here and this low pressure system comes up, you know, depending on what the upper levels look like for that low, you know, pushes up and rides up over that high pressure system, then you have all that precipitation falling through the high. The low freezing level then you'll get the snow on the ground. So that line, the 540 line, is what pretty much determines that freezing level is going to be low enough to be snow. If it's the freezing level is less than 600 feet, 600 feet or less, you'll get snow. If it's between 600 and 1200, you'll get mixed precipitation, rain and snow. And then if it's above 1200, you're going to get rain. So you can have a warm layer in the upper levels too. Say you'll have a cold layer on the surface, a warm layer in the middle above that, and then another cold layer. So you have frozen precipitation in the upper levels. That'll fall, come down into a warmer layer, and then it'll partially melt. And then when it hits the cold layer on the surface, then it could either refreeze completely or partially refreeze, and then you'll get the snow grains, you'll get the ice pellets, you get different types of precipitation because of that. So looking at this chart, almost looking like a kind of a trough a little bit right here. So your initial reaction would be put the warm front there, and then the low pressure system, like I said, it has it over the Gulf. But looking at these wind barbs, you could have your rotation about right there. That's pretty close. I mean, you have a low there, it could be right there, and then your cold front with the winds coming out of the northwest. Let me clear this out real quick. So you got the winds from the southeast, winds from the northwest. Your frontal boundaries pretty much right through here. Now that one is just the 5-knot wind. That could be, you could have some backing because of friction, anything going on there. This one's out of the northwest, so keep your front south of that, and then just kind of ride them thickness lines. Let me get out of this for a second so I can pull this up just a little bit. So now actually, if you push this wind from the north, there's a shift there, there's a shift here, right there, so you could almost go the cold front right through here, which is really no advection over here. So you're looking at for the wind to blow around this low, it's going to be pushing pretty hard, so you're kind of looking right through there over Mexico. Let's see what happens there. And with that precipitation, that's kind of where we were. Refresh this thing. Okay. Now, the frontal boundary coming down the low pressure system, the warm front. You see those bands overriding that cold air. You got warm air advection, your warm sectors here, so your warm air pushing over the colder air, and then your cold front was over right through Texas, or through Texas and Mexico. So that's just an idea. That's just basic analyzation there. Nothing serious on the forecast. Now, as this low develops, what you can get is the frontal system. Let me get my drawing back up. With the frontal system coming down, as that frontal system starts to slow down, so that high pressure was over Illinois pushing to the southeast. As it starts to stall, we had that stationary front, because we had the high out here, then this whole system just kind of sits there. Excuse me. That frontal system just sits there. Now, with the low pressure system developing along that front, then you start getting the rotation. Now you end up with another warm front, another cold front. So then you get any lift at all up in the upper levels, that can cause that low pressure system to develop right over that front. And then that's where you'll get a whole nother system develop. This stationary front, this will push out. This low high pressure system will push out, get absorbed into that high. This frontal system just dissipates, and then you'll get the low pressure system develop off of that, and then that'll push to the northeast. You know, keep an eye on the jet stream where that is, and then, you know, it's more like kind of like this probably, and then that's your steering flow, and that'll push to the northeast. It could stay south. All depends on what these highs do. If this high pushes out, absorbs into that high. If they split and that just kind of sits there, where that low pressure is going to go and where that high pressure is going to allow it to go, because high pressure always rules. So another tool we can use off the charts, I can run, let me erase that. I can run a surface frontal genesis. This will tell me if the best areas for the development of a frontal system is the frontal system getting stronger. Frontal genesis is the beginning of or the increasing in intensity of a frontal system. Alright, so let me get this back. Try to get this moved here. Running slow. Well, I'm not done yet. It's still loading. Try to move the screen while it's loading. It just runs a little bit slower. Alright, so that should be it. Now, there's the fronts that the computer model, this computer system is analyzing and putting the fronts in that onto this chart. But let me add some isobars to this thing so we can see what's actually going on. It's already got the highs and lows, so I want no highs and lows. Let's go. This frontal system's all crazy. I can see, you know, that frontal system. Let me get my draw tool up here. There's the low up there, occluded front coming down, cold front, and I'd say right along the east coast. Like I said, went stationary between these two highs, because the winds around that high is in this direction, the winds around that high is in this direction. That low is just, that computer's wrong. This frontal system, you know, I'd put that front right into that trough, and then coming into this trough off of that low, and then back into this low pressure system. This could just, that's nothing. I mean, you could have a frontal system and then a prefrontal trough, but that's not likely here. This is, you know, there's no advection. Nothing happening because of the low pressure system. I think the computer sees a high, and then it sees the other high, and then it wants to put a low there because that's the way the system works. But as long as you got a frontal boundary, it has to be stationary if it's between two highs, because you're in directions, and then coming back into that low. So now, with this low pressure system, frontal genesis, like I said, the, you know, upper levels, that gives this low pressure system and the fronts a good chance of development. So that's this chart's pretty good for indicating, is that system going to strengthen, and based on this chart it will. So this high pressure most likely move out of the way, you know, could move, most likely going to move up to the southeast. That low pressure system pushes off, and then this low pressure system develops even more and takes off. Now this low is just kind of showing on the surface with more or less a trough, a little bit of advection. Yeah, that's a pretty good low. I mean, it's okay, it's not real intense. The upper levels is where that low is going to be the strongest. So when that low pressure system starts to push over, you know, it can't push that high all the way. The high is going to do what it wants, and it's going to let the low pressure system move where it needs to move based on the jet stream and the steering. So most likely the upper levels of this low is going to, because if this low is stacked, you know, it'll be stacked into the upper levels. It'll start to be low pressure, low pressure, low pressure at the upper levels, and then start pushing through and then riding over this high pressure system, which is on the surface, and then any precipitation that falls through the cold air, and then wherever that 540 line was, then anything north of that's going to be snow, anything to the south is going to be rain. So that's a little bit deeper than I wanted to go on this video. I just wanted to kind of show you frontal placement. You know, this computer does it its way. You got to take that data, and once you put that surface data on these charts, then you got to verify based on wind directions, temperature drops, dew points, you know, there's several things that will tell you the exact placement of that low or that frontal system. So I hope you learned something from the video. If you liked it, if you did learn something, like, share, subscribe if you feel like it. And thanks for watching.